Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Nazmin bin Mohamad Azhar, a student from Bachelor of Surveying Science and Geometric with Honours Program at University Technology Mara, UITM Malaysia. Today, I will be presenting about my final year project entitled Reliability of Trigonometric Leveling in Establishing Vertical Control for Multistorey Structures. Before we start, I will briefly explain about the background of this study. As we know, trigonometric leveling or TL is widely used for establishing vertical control in multistorey structures. Based on previous study, Recke et al. Had demonstrated that trigonometric leveling can achieve satisfactory accuracy for floor planarity assessment. Meanwhile, for PT and Hospers also mentioned that trigonometric leveling is capable in producing reliable elevation measurements for engineering surveying. Because of that, this study used to compare two types of methods, which is the first one is direct method and the second one is intersection method, to evaluate the reliability of trigonometric leveling under high gradient slopes. For the objective is to experiment with a variant of the 3D traverse network involving a high gradient slope. Now, we will move to the next part, which is methodology. Starting with study area. The study area for this research is at Alpha-Arbitrary building, specifically at Block A. This building consists of 3 to 4 floors. This building also was selected due to suitability for vertical control measurements using trigonometric leveling. Prior to the trigonometric leveling survey, 12 control points were established using the GNSS STAC SV1. The RTK-based rover method was employed to establish the control points before proceeding with the trigonometric leveling observations. After the establishment of control points, the trigonometric leveling work was carried out by using the two types of method, which is direct method and intersection method. For direct method, instrument is set up at one control point only. Vertical angle and slope distance are measured to each target point. Height difference is calculated using trigonometric principle. And then, for all elevation, for all target point is determined relative to the control points. Meanwhile, for the intersection method, instrument is set up at two different control points. Vertical angle and slope distance also are measured to each target point from both setup. Elevation is computed independently from each setup. For the final elevation is taken as the mean of the two computed elevation. For the software, there is two types of software that can be used. First one is Microsoft Excel to sort all of the data that have been taken at the site. Second is AutoCAD 2025 that is used to give an illustration based on the data that have been taken. Now, we will move on to the results and discussion. The first graph shows is elevation versus target points. As we can see here, both methods produce almost identical elevation profiles across all of the target points. The direct and intersection methods follow the same elevation trend for floor 1 until the floor 4. The two lines overlap closely, indicating strong agreement between the both methods. From this, we can conclude that the both methods successfully transferred elevations throughout the multistorey buildings. Third graph here shows about the difference between the reduced level versus target points. What we got here is most target points recorded a very small elevation difference. The differences will distributed around the zero reference line, indicating no systematic bias between the two methods. The maximum difference was approximately around 16 millimeters, while most observations were considerably smaller. Statistical analysis was carried out to compare the elevation results obtained from the both observation methods. The difference between the both methods were computed for all of the target points. As we can see here, the mean that we got is around 3 millimeters, meanwhile for the standard deviations are around plus minus 6 millimeters. For the key findings that we can conclude here is the mean difference is very close to the zero. indicating excellent agreement between both methods. The maximum and the minimum difference are very small, showing that the elevation from both methods are highly consistent. The standard deviation indicates low variations, demonstrating good reliability of the observations. To be concluded, both the direct and intersection method had already produced a highly comparable elevation results. The mean elevation difference of 3 millimeters and standard deviation of plus minus 6 millimeters indicate a high level of agreement and consistency between both traverse network variants. Although slight increase in elevation difference were observed at the upper floors, both methods exhibit a similar elevation strength throughout the multi-story structures. Based on the statistical comparison, both traverse method variants demonstrated consistent performance in transferring elevations under a high gradient slopes. I think that's all for my presentation today. Thank you.